This is the review for AP Chemistry Unit 3, and these are the topics. First is the intramolecular forces. It is the chemical bonds, and it determines the chemical properties of a substance. So unlike the intermolecular forces is the chemical bonds or the forces between the atoms, not the molecules. Electronegativity determines the bond type, and greater the difference in electronegativities. If it's between a metal and a nonmetal, it will be more ionic, and if it's between two nonmetals, it will be more polar. So for example, H and H, the difference in electronegativity will be 0, so it will be nonpolar. H and Br will form a polar covalent bond. Lithium and fluorine will form an ionic bond. This will be a quick review for you guys. So ionic bond is between a metal and a nonmetal, and it requires a transfer of electrons. It's very strong, and it is a crystalline solid at room temperature. It has high melting or boiling points. In liquid and aqueous state, they conduct electricity. Next is the covalent bond. It is between two nonmetals, which requires sharing of electrons. It is very weak, and they are liquids or gases at room temperature. There are two types of covalent bonds, which are polar covalent and nonpolar covalent. Polar covalent can interact with other polar molecules and cause a dipole moment. Next is the intermolecular forces between the molecules, not between the atoms like intramolecular forces. The energy needed to break the bond is same as the energy released when forming a bond. Bond energy is the energy required to break the bond, or energy released when a bond forms. So potential energy is the distance between the atoms, and lower the potential energy, the shorter the distance between two atoms. Between two atoms of different charge, there will be low potential energy because the distance between those atoms will be small. And two atoms of like charge, which will repel each other, will have higher potential energy because there will be a longer distance between those atoms. And this is the graph of potential energy. When the potential energy is the lowest, the atoms will be in the most stable state. Bond order is the number of bonds between two atoms. As the number of bonds increases, the bond length decreases because attraction between the atoms will be stronger, and they will attract each other more strongly, which would make the bond length smaller. As you can see, in single bond there will be 2 electrons, but in double bonds there will be 4 electrons, and in triple bonds there will be 6 electrons. So the attraction will get stronger and stronger as you go down, and the bond length or the potential energy will decrease. As electron density increases or the charge increases, the force of attraction between protons and electrons will increase according to the Coulomb's law. As the attractive force increases, the bond energy will increase as well because more energy will be needed to break the bond. And as atomic radii increase, the bond length will increase as well because the distance between the nucleus and electrons will be larger, and bond energy will be lower because it will not take as much energy to break the attraction between larger atoms. Next is the structure of solids. First is the network covalent solids. There are diamond and graphite, for example, and the atoms are held together chemically by intramolecular bonds. So they are the strongest, very strong, and they have a very high melting point. And they are non-conductors. You can simply think of diamond. Next is the ionic solids. Cation and anion held together by electrical attractions, which is intramolecular bond. And they are non-conducting solids, but conduct electricity in liquids or aqueous states. They have high melting points and they are brittle. Next is the molecular solids. There's ice, and they are held by intermolecular forces. Like ice, water molecules held together. They are the weakest type of bonds, and they have a lower melting point. And the last one is the metallic solids, which you can think of iron or silver. A metal atoms are held together by a sea of electrons. They do have a high melting point, malleable, and they conduct electricity. Next is the alloy. There are two types of alloy. Interstitial alloy is consisting of two different sizes of metals. So you have the bigger size and a smaller size. So they have a different radii, and smaller atoms do not substitute larger atoms, but they just go in between them. For example, there's steel. And next type is a substitution alloy. It's similar size metal replacing another metal. Next topic is the Lewis structure. Drawing Lewis structures is very important, and you will have to know how to draw them correctly and in a short amount of time. So first, you have to count the valence electrons by looking at the formula. And then you have to put the least electronegative atom in the center and connect with terminal atoms. And you have to complete the octet for all terminal atoms and then add up the number of electrons, subtract them from the total number of valence electrons that you got in the first step. And then you have to attach leftover electrons to the central atom as lone pairs. And then you have to make double or triple bonds if needed. So we are going to do some practice here. So first, iO3 minus. First, as it says, you have to count the number of valence electrons. You have 7 for iodine and 6 for oxygen, but you have 3 of them. And then you have to add 1 because you have a charge of -1, which means you have an extra electron. So you have 27 electrons total. Put the least electronegative atom in the center, which is iodine. And then you have to connect with terminal atoms, which would be 3 oxygens. You have to complete the octet for all terminal atoms. So you complete the octet for all 3 oxygens. And then you add up the electrons you have, which is 8 times 3, 24. Then you subtract it from the total number of valence electrons. So you do 26 minus 24, which is 2 electrons. And then you attach the leftover electrons to the central atom as lone pairs. So you put 2 atoms here, and then you check if all the atoms satisfy the octet. And then you cannot forget to put this bracket because it is a charged molecule. Next, you have the ozone, O3. You have to count the number of valence electrons, 6 times 3, 18 electrons. And then you have all oxygen, so you can just put oxygen like this. And then you complete the octet for terminal oxygens. Then you count them, and it's 16. 18 minus 16 is 2. You put the leftover electrons to the central atom, and you see that the central oxygen does not satisfy the octet because it only has 6 electrons. So you will have to make the double bond here, and you can do it on either side. You erase this and then put a double bond here. Then you can see that all oxygen atoms satisfy the octet. They all have 8 electrons total. For the last example, you have a little exception here. You first have to count the number of valence electrons. 4 times 7. 36 electrons in total. And you put the least electronegative atom here, and then fluorine as terminal atoms. Draw the octet for all terminal atoms. And then you count them up. 36 minus 32, which is 4. And you have to put these 4 electrons to the central atom, even though it already satisfied the octet. And that is why I said it's an exception. Xe atom can have 10 electrons total. And that is an exception of expanded octet. Next topic is the resonance structure, multiple possible Lewis structures. So for example, NO3- can have this Lewis structure, 2 single bonds here and a double bond here, but double bond can go to any terminal atom. So you have 3 possible Lewis structures, which is a resonance structure. Next topic is the formal charge, which is very, very important. You cannot finish the Lewis structure without checking the formal charge. It is calculated to identify the most stable or likely structure that the molecule will have. And more likely, Lewis structures will have formal charges closer or equal to 0. Negative formal charges should reside on the most electronegative element. And formal charge is the number of valence electrons minus the number of unshared electrons plus 1/2 of number of shared electrons. And I will show you how to do that here. And you can simply just count the electrons that each atom has. So for hydrogen has a valence electron of 1 minus unshared electrons are 0. Then shared electrons are 2, but you have to do 1/2 of it, so it will be 1. So this will be just 1 minus 1, 0. Hydrogen can only have a formal charge of 0 because it can only make one bond with other atom. Without doing all this unshared and shared electrons, you can just count the bond or unpaired electrons just as 1. Because if you share electrons, it will be 2, but you have to do 1/2 of it, so it will just be 1. So you can just count the bond as 1. So for oxygen has a valence electron of 6, and you subtract the number, you just count them, 1, 2, 3, 4, 5, 6. And then you will have a formal charge of 0. And for nitrogen, it has a valence electron of 5, and minus, you just count them, 1, 2, 3, 4. So the formal charge of 1, and for oxygen atom in here, you do 6 minus 1, 2, 3, 4, 5, 6, which will be 0 again. And then for this oxygen over here, 6 minus 1, 2, 3, 4, 5, 6, 7. And you have -1. And you see that this Lewis structure follows all the rules because the negative charge resides on the most electronegative element, which is oxygen in this molecule.